Hi, welcome to my channel Industry 4.0. IoT with blockchain may take real reliance on captured data. The underlying idea is to offer devices, at the time of their creation, an identity that will be validated and verified throughout their lifecycle with blockchain. In this video, you will learn how does IoT work with blockchain. Please like and share the video and subscribe to my channel. So, let's start. Introduction. IoT allows devices across the web to send data to non-public blockchain networks to make tamper-resistant records of shared transactions. Blockchain has been long touted because the perfect technological complement to IoT systems. IoT with blockchain may take real reliance on captured data. The underlying idea is to offer devices, at the time of their creation, an identity that will be validated and verified throughout their lifecycle with blockchain. There's great potential for IoT systems in blockchain technology capabilities that believe in device identity protocols and reputation systems. With a tool identity protocol, each device can have its own blockchain public key and send encrypted challenge and response messages to other devices, thereby ensuring a tool remains on top of things of its identity. Additionally, a tool with an identity can develop a reputation or history that's tracked by a blockchain. Description: Blockchain allow devices. Independent IoT devices in today's networks don't exist as independent entities outside of their centrally managed networks. As far because the outside world cares, they're handling an outsized server sitting within the cloud that has some data, with no idea of the provenance of the info or any means to interact directly with the devices that collected the info within the first place. On a blockchain network, each node, any participant connected to the network, has a singular private and public key pair that uniquely identifies it as an independent participant on the network. Exactly, these characters are enforced largely using cryptographic signatures or digital messages that unmistakably identify the sender. Having unique identities is the foundation for achieving independence, giving each device the power to act on its behalf. This permits a decentralized mesh topology instead of a centralized server-client topology, with each node ready to make its own decisions and, more importantly, to form use of its own resources independently of the opposite nodes. This sort of network is far safer because hackers cannot gain control over many devices by hacking one server. Rather, the hacker has got to compromise many devices one by one, with each compromised device likely to be rejected by the network for misbehavior, leading to the hacker taking up a useless, disconnected device. A decentralized network with a sensible consensus algorithm is additionally far better at balancing workloads that were formerly handled by one entity. This makes network deployment also as maintenance far less expensive because the workload of connectivity, storage, and even computation can now be done by many devices within the network, without the necessity for a costly centralized arbiter. Blockchain allows devices awareness for ownership. Blockchain also endows devices with the concept of ownership through the exact same cryptographic primitives that guaranteed unique identities. Any device can now sign for also as encrypt any sort of digital asset it's access to. Specifically, a tool can now own cryptocurrencies also as other sorts of assets that it's control over. By having this idea of ownership, the IoT device is now an independent economic entity ready to not only act but act in its own best economic interests. For instance, rather than remaining idle, a tool might plan to put its capabilities on auction and collect customized data on demand. To avoid obsolescence, it could network with other related devices to deal order a firmware upgrade, etc. While they like fantasy, these examples might not be too far away in the future. Ensuring ownership of digitized assets also assurances the privacy of the asset maker. Without the specific permission of the originator, example, without a decryption key, nobody can access the info. Today's widespread, and, more importantly, hidden data collection and aggregation processes are going to be delivered to the forefront and made to hunt explicit permission from the info generator and owner. Blockchain enables devices to trade. What does an independent, asset-owning economic entity do? It trades with other independent, asset-owning entities. At the core of each blockchain network may be a consensus algorithm that creates sure every node on the network agrees on the network's historical set of state transitions. Other merely, what is changed about the network? This consensus allows the important functionality of blockchain, decentralized trading of digitized assets. The ability to securely trade assets and resources becomes even more consequential once you consider the worldwide ecosystem of open source developers that are naturally a part of any open source blockchain ecosystem. Now there's how to reward and enable better usage of the info collected by devices in a decentralized manner. Any device or a network of devices can prefer to publish a segment of its collected data and put up a bounty with a selected objective on the blockchain marketplace, locking the reward during a cryptographically guaranteed smart contract, and incentivizing people to get and be rewarded for the answer. Learning uses for data was a mainly difficult problem for a centralized entity, but with blockchain, it could potentially become a way modest decentralized problem, tapping into a globalized talent pool from everywhere on the planet. Current limitations. Some of the key limitations of the system are listed below. Their absence of a mainstream, obvious low latency, high amount blockchain network designed exactly for IoT devices. Device producers have up till now to embed cryptographic keys into each piece of hardware or make them blockchain compatible as a generalized standard. Software cryptographic methods to assure privacy-preserving computations are grossly inefficient and not practical, though hardware solutions require trust within the manufacturer and therefore the entire manufacturing supply chain, making it difficult to guard against data piracy. Artificial intelligence isn't sufficiently sophisticated to enable such extraordinarily autonomous decision-making behavior in devices. Legal recourse remains required to further de-risk trading over blockchain, but only limited jurisdictions have recognized smart contracts on blockchain as legally binding contracts off-chain.